let's get to this practice called pause 1. Alright, first, we're going to name the plane. We can call this quite a few different things. First is plane R. Whenever there's a capital letter there without a dot next to it, that's because somebody wanted to name that plane plane R. And I'll also call that plane ABD, plane ABE, plane BCD, plane BCE, and how about plane CDE? If you switch these letters around, then it's the same plane, ABE, but that's all of them. You don't want to call a plane ABC, since those are collinear. It doesn't make it a unique plane, so make sure that you got 3 dots that are kind of staggered. Next, we're going to name 3 collinear points. So what 3 points are all in the same line? I've got A, B, and C. As an option, I don't see any other 3 points. We got 2 points, but not 3. So that's it. Name 3 coplanar points. Now we can say any of the points that are on there. A is on there, B is on that plane, C is on that plane, D is on that plane, E is on that plane. So you can use any of those that you like, or any 3 of those that you like. Next, you can name an array. Let's do BA. It is important that you're going in that direction from BA out that way. Technically, you could go AB, goes the other way. Now we've got BC, BC going that way. We got CB going this way. Again, it is important to make sure that you're showing the direction that's going. And technically I would have AC and CA also. AC, CA. CA going that way, or AC going this way. Name a line. Alright, I'm going to start with the easy one. I got line fancy L there. So I've got line L. I can also name them now. I've got line AB. Goes on and on in both directions. I've got line BC going on and on in both directions. I've got line AC going on and on in both directions, and then that would be it. You could also do BA, CB, or CA. Those would also work. Next, I'm going to name a segment. I've got AB. This just has a line above. There's no arrows. That represents a segment. AB or BA, BC or CB. I've got AC or CA. I've also got BD here. BD. Alright, so if this were a quiz, I'd probably give 1 point for each of these. Alright, next, number 7, I'm going to find RT. I know that using segment addition postulate, that RS, this segment, plus ST, that segment, equals the entire segment, RT. I know that RS is 32. I know that, plus sign. I know that ST equals 63. That equals RT. So if I add those together, 95 is the length of RT. I'm going to put a box around it so I know that that's the answer. If this were a quiz, I would give this 2 points. Number 8. Same type of problem using segment addition, but some of the segments that we know are in different places, so I'm going to write it out. LM plus MN equals the whole length, which is LN. I don't know LM, that's what's asking me to find. MN is 62 and LN is 80. A little bit more work than the last one because I need to get LN by itself. Since I'm adding 62, I have to use the opposite, and that is subtracting 62. So I get LM equals 18. And if this were a quiz, I'd get 2 points. Number 9 is also segment addition, but I have to do a little bit more work. I've got FG plus GH equals the whole FH. I don't need to write that every single time, but it is a nice reminder. So now that I'm plugging these in, FG is 2x minus 10 plus GH, which is 3x. The whole thing equals FH, which is 50. Now I want to get my x's together, or like terms. So combining them, I get 2x plus 3x is 5x. I still have this minus 10, so I'm going to bring that down, equals 50. Need to get the 5x by itself, so I'm subtracting 10. Opposite operation is adding 10. That will help that go away. 5x equals 50 plus 10 is 60. Divide by 5, because 5x is really 5 times x, and the opposite of multiplication is division, so I'm dividing by 5. That'll help me cancel that out, and I get x equals 12. This is where you might feel like you're done, but you're not, because it's asking for FG and GH, which is the length of those, and right now they still have x's in them. So I need to take this 12 and plug it in to each one. So starting with FG is equal to 2x minus 10, and I've got to plug in that 12 right there. So that equals 2 times 12 minus 10. 2 times 12 is 24 minus the 10 equals 14. So FG equals 14. The most typical way to solve for GH would probably be just plug that in also. GH equals 3x, and the x is 12, so it's just 3 times 12. That equals 36, so GH equals 36. Another way that you could have solved that is, now that you know that this is 14 up here, you could have taken 50 minus 14, you could have got that number much like you did in number 8. Alright, this one was a little bit more work. You have to find x and then plug it into 2 different places, so I'd give this 3 points. Moving over to number 10 now. Number 10, y is the midpoint of xz. Find xz, the length of xz. Well, if y is the midpoint, then I know that these two parts are congruent. Those two segments are congruent. That means the length of them are equal. So this must also be 17. So to find the whole length, using segment addition. And you don't really need to write this out. I like to write it though. This part plus this part equals the whole part. We know that that's 17. XY 17. We figured out because it's the midpoint that YZ is equal to 17. We still need to find the whole length. And 17 plus 17 is 34. So I just found the length of XZ. That'd give me 2 points for that. Now moving on to 11 and 13, I have to use this diagram on both. First, identify the bisector. A bisector is something that cuts a segment into two parts. So here, one of the bisectors is that point K. Technically that in the middle is cutting it in half. Or you can think of it as line M here cuts it in half. So I take either one. Give myself a point. Point K in the middle is what type of point? Well, it's a point in the middle. We know it's a bisector. So K is a midpoint, or the midpoint of JL, that segment. Lastly, I need to find JK and KL. Again, because I have these two tally marks, it lets me know that these two parts are the same or equal. So JK, which is 5x minus 3, must be equal to 4x plus 7. So I'm going to solve for x, get the x's by themselves. So I'm going to subtract 4x from this side and bring it to the left. This cancels out. 5x minus 4x is just x. I'm going to bring on down anything I didn't use yet, so there's negative 3 equals 7. You need to get the x by itself, so I'm subtracting 3, so I need to add 3, the opposite operation to get rid of it. I get x equals 10. I'm not quite done, and you guys know that this is one of the most common ways for students to miss points. I need to take that x and plug it back in to find out those lengths, because it's asking for the length of JK and KL, not x. So plugging it back in, that 5x minus 3, and plugging in 10 will give me JK. So 5 times 10 minus 3 equals JK. 50 minus 3 equals JK. And then subtracting 3, I got 47 equals JK. So that tells me JK. KL, 4x plus 7. The x is going to be 10. I'm plugging that in. So 4 times 10 plus 7. 4 times 10 is 40. Plus the 7 tells me that KL equals 47. So what's another way I could have solved that? Well, I do know that it was bisected, so this segment should be the same as that one. So as soon as I got 47, I should have known that the other one was going to be 47, right? Because they both have to be the same. But it's nice to do them both, because then I get to check and see if I did the math right. And I did. So for this one, I give myself 3 points, and I would have given myself 1 point for the one above for the midpoint. So for this, it's out of 20 points.